All right, so let's go ahead and go through number 10, the one that we're supposed to do last night for homework. All right, so remember, our goal with these rate laws is to figure out a relationship between the concentration of each of our reactants and the rate at which our reaction proceeds. So we need to do this in two steps. Our first one, looking at how our NH4 concentration affects how fast our reaction goes. Okay, so when we're looking at NH4, we want to find a reaction where NH4 is changing and our other reactant, our NO2 minus, is constant. So we're going to look at reactions 2 and 3. Okay? Because we only want to focus in on how that NH4 is affecting our rate. So what we're going to do is we're going to take experiment 3 and divide it by experiment 2. Okay? The reason we want experiment 3 on top is because our rate there is larger. Remember, we want the larger number on top. All right, so we're going to write our rate law for each. So experiment 3, we have 5.4 times 10 to the negative 7 is equal to our constant times the concentration of NH4 plus, or 0.2 raised to some power, times our concentration of NO2, 0.01 raised to some power as well. We're going to do the same thing for reaction 2. Their rate is 2.7 times 10 to the negative 7, set that equal to K, times our concentration of NH4 raised to some power, times our concentration of NO2 raised to some power. Okay, so now we can look and see what is the same on top and on bottom, and those will cancel. So if we have a K on top and on bottom, those will cancel out. Same thing with our 0.01 N. Okay? So now we can really only focus in on our rate and our concentration of NH4 plus. Okay? So in our calculator, we'll do 5.4 divided by 2.7, and we'll see that increases by a factor of 2. Same with our concentration of NH4 plus. Okay? So 2 raised to some power has to equal 2. That tells us that M is 1. Okay? So that's for the NH4. We're going to do the same thing looking at our NO2. There, we want to pick 2 reactions where NO2 is changing, but our NH4 is constant. That's going to be reaction 1 and reaction 2. Okay? So what we're going to do is we're going to take reaction 2 and divide that by reaction 1. Okay? So when we look at our rate, we'll have 2.7 times 10 to the negative 7. Oops, here, I'll scooch this down a little bit so I don't run out of room. All right, so 2.7 times 10 to the negative 7 is equal to our constant times our concentration of NH4 raised to some power times our concentration of NO2 raised to some power. Okay, we'll do the same thing for reaction 1. 1.35, our rate, is equal to our constant times our concentration of NH4 times our concentration of NO2. Okay, so again, whatever is on top and on bottom cancels out. We have a K on top and on bottom, those cancel. Same with our 0.1 M's. Okay, so now we can look and see by what factor is our rate increasing. Our rate increased by a factor of 2, and so did our concentration. Because 0.01 divided by 0.05 gives us 2. So that means our N also has to be 1. So our reaction is first order in respect to NH4 and NO2. Okay, so when we want to write our rate law, our rate is equal to our constant times our concentration of NH4 plus raised to the first power times our concentration of NO2 minus raised to the first power. Okay. So then for B, when we want to find the constant, we want to find that K. How we're going to do that is here. We'll do that underneath. So we'll just ignore this right now. What we're going to do is we're going to pick one experiment. I'll just pick the first one. And we're going to plug our values into our rate law. So there our rate is 1.35 times 10 to the negative 7. Don't know K. Concentration of NH4 plus is 0.1 raised to the first power. Concentration of NO2 minus is 0.05 raised to the first power. Okay? So when we want to find our constant, we're going to divide by 0.1 and divide by 0.005. And we should get a constant of 2.7 times 10 to the negative 4. Okay? You do not need to worry about the units. We're not going to focus on that. Okay? But once you know your rate law, just plug in some values and figure out what your constant is. Okay? So I hope that helped. Go ahead and work on the rest of the problems in that packet. 11 through 16. Keep in mind that number 14 is pretty tricky. So just know that's a little more challenging than what you'll usually see. And then I'll send out the answer key so that you can check your answers. All right, let me know if you guys have any questions, okay? Good luck.